All right, today's lesson, exercise 18C. We're going to now talk about stationary points. Remember, chapter 18 is all about applications. So you're going to be applying your derivative rules. Hopefully you've learned all your 6 rules, chain rule, and then product rule. Okay, 6 rules plus chain rule and product rule. Once you know those rules, chapter 18 is all about applying, analyzing functions, and then solving, say, maximum, minimum, domain, range. All of that will start to come in. And stationary points is one of your big ones. Okay, so here we go. Now, what is a stationary point? A stationary point is classified when delta y, delta x equals 0. You get a mark in year 12 when you're doing stationary point problems. So they'll say justify that it has a stationary point or a maximum at wherever it is. You get a mark already by stating, and you, no matter how you do it, you just have to state that you know stationary points occur at or when, I'm just going to write at, shorter, at delta y, delta x equals 0. Okay, so this is the first step. No matter which problem you do, if they ask for a maximum, a minimum, a stationary point, justify it, you have to have that step to begin with. What most students do when they jump right in, so I'll give you as an example over here. So they say find stationary points. Most students will jump right in and do 0 is equal to, and by this point, most students are really good at their power rule. So you'd find the derivative, and then you would say 12 minus 4x. Don't do that. Okay, because what is this? Where'd that come from? What does it represent? They don't give you a mark for that. Technically, I know what you're doing. They do know what you're doing, but they're going to assume that you don't know anything. So therefore, it's like, what did you let equal to 0? Is it y equal to 0? Where is this number coming from? So my encouragement is you should write, and you don't have to write, you could write stat point. So you could do stat pt when delta y, delta x equals 0. That's fine as well. You just need to state somewhere that you understand stationary points occur then. Okay? Now, let's unpack that. Delta y, delta x is the derivative. So when I say the derivative equals 0, what am I really talking about here? When you find the derivative, what are you trying to find? The gradient of a tangent line. Okay, it's the gradient of a tangent line at one point on the function. So when they say the gradient of this tangent line that you have, so gradient of tangent line, if they're saying the gradient of it is 0, let's have a think about our gradient line or the tangent line. Y equals mx plus c. If this was my tangent line and I'm saying the gradient is 0, what does that look like? A tangent line with a gradient 0, what does that look like? C. And if you were just to sketch y equals to c, that's just a horizontal line. Y equals c is just a line. It's a horizontal line. So they're trying to say that when you have a curve, okay, so it doesn't matter what the curve is. I'm just going to draw a random curve there. They're trying to say no matter what gradient you're choosing, it's when the gradient of this tangent line is flat. So in this line here, we can see if I picked a point here, right, that point right there, you would then say the gradient of a tangent line would be something like this. That's a positive line. That has a gradient line. But I'm not looking for positive. I'm not looking for negative. I'm looking for when the gradient is 0. Now you can see over here, this is negative. That's a negative gradient. So where would 0 have to be? You can sort of picture this. If that's a tangent line at this point, and as I move around that curve, these are the tangent lines. It's positive, and it gets, as I'm moving across, you can see that the tangent line is getting flatter and flatter and flatter. At some point, it went from positive gradient to negative gradient. So to go from positive to negative, it had to cross 0. And that 0 is right at the maximum. At the very highest point, the tangent line to it is horizontal. Okay, so that's why when they talk about stationary points, what they're really talking about is the turning points. At every turning point, you have a gradient of 0. Whether it's a maximum peak or a minimum peak, there has to be a gradient of 0. That tangent line is going to be flat. So this is where exercise 18C gets you to find the maximum or turning points of any graph. Now remember, back all the way in term 1, there was a formula that I gave you for quadratics. And I told you that I can't teach you where it comes from until you learn derivatives. It was this one. So remember in quadratics, I gave you like a chart. I said that finding x-intercepts was the hardest one. You had to learn, quad rule, quadratic formula. You had to learn how to factorize. And under factorize, you had complete the square. You had dots. And you also had the factorizing by trinomials, right? Those are the skills. But under this column here, there was the turning point form. So it looks something like y equals a bracket x plus k squared. That was one way to find the turning point, but I also gave you another formula. Anyone remember what that formula under this category was again? When it comes to finding the turning point of y equals ax squared plus bx plus c, I gave you a formula. One formula to find the turning point if you didn't know how to complete the square. There was a method. Anyone remember what that formula was? Because I'm going to show you where it comes from now. And what was that one? You can complete the square, but let's say if you didn't know how to complete the square, I gave you one formula to do that.
X equals negative b over 2, right?
Very good. This one just gives you the x coordinate of your turning point. So back in term 1, to find the turning point, you needed to find the axis of symmetry. This was the formula I gave you at the start of the year, and I told you, just trust me, just learn it, but I will teach you where it comes from. Now I can show you where it comes from. You now know how to do power rule. Now you're learning the idea that at any turning point, so any graph you get, see any quadratic graph you get, there must be this maximum where the tangent line has a gradient of 0. Or here, at a minimum, it has a gradient of 0. So you can find the turning point when you know the derivative has to be 0. So if I know that I can find the derivative, see these points, that's a maximum, that's a minimum. This formula is actually you figuring out where on the x-axis will you have a gradient of 0. So how do you do it? Well, this is where it comes from. If you have y equals to ax squared plus bx plus c, and you wanted to find the derivative, so let's do that. Delta y, delta x. You're now using your formulas, power rule. A is just a constant, so you leave that as it is. So this is still a times what's the derivative of x squared? This is x squared here. What's the derivative of x squared? 2x. So I'm going to write here, I'm going to write times 2x plus, again, b is a constant, so you leave b as it is. But then what's the derivative of x? 1. Very good. And so this now becomes b times 1, but then what's the derivative of c? A constant number. What's the derivative of 3, derivative of 4? What is it equal to? 0. Derivative of any constant 0. So what you end up with now is you have delta y, delta x, which is the derivative, is equal to 2ax plus b. Now if I want to find a turning point, we knew that turning points occur when the derivative equals 0. So that's my derivative for any quadratic equation. Doesn't matter what quadratic equation I get, that's my derivative. So I know that at the maximum or at the minimum, the derivative has to be 0. So that's what I write. And this is the part of your layout. When you're doing this in year 12, you should then be saying here, maximum or minimum occurs when delta y, delta x is equal to 0. If that's true, well then this now becomes 0 is equal to 2 times ax plus b. So in your quadratic graph, doesn't matter where it is, we're trying to find where is this x value so that the gradient is 0. So how do you find x? Well, rearrange that equation. Rearrange that and find what x equals to. And this is where the formula came from. Minus b on both sides equals 2ax. I want to get x by itself. Divide both sides by 2a. 2a divided by 2a is 1. That's why that x coordinate of your turning point over here, the x coordinate must then equal to negative b over 2a. That's where it's coming from. It's coming from the fact that we understand that the maximum or the minimum, if I were to draw a tangent line at the turning point, it has to be 0. So I found the derivative, I let it equal to 0, and I solve for x. That tells me where on the x-axis. Okay, so now with that understanding, you see this exercise 18C, all you're doing is find the derivative, let the derivative equal to 0, solve for x. What that tells you is where on the x-axis will you have a tangent of 0. And that's what this diagram is trying to show you, where it's 0, 0, 0. Okay, so the first step, you can't do stationary points if you can't derive. No matter what skill you do, if you can't derive it, you can't find the stationary point. Yeah. Correct. Yeah. And that's where 18D comes in. So right now I'm teaching you how to find stationary points. 18D, which is what Andre is asking, is that the same for inflection points? Yes, it is. Because that is, when you think about an inflection point in a cubic graph, they eventually go positive, positive, 0, and then positive, positive again. Okay, so that is an example of a stationary point, and that's 18D. So in order to do them, you have to understand, well, what is the stationary point? That's what you're doing in 18C to begin with. Okay, so we're going to do some examples. Let's do an example just to get you going. Let's say 18C, right? I'm going to pick a question. Let's do, what's one that you're kind of a bit more familiar with? Let's do E, okay? Let's do E. They want you to find the coordinates. Keyword there is coordinates. I'm just going to screenshot this. Here we go. Let's find the coordinates of the stationary point. So most students, when they read this question, they're only giving me the x. When it says coordinates, they want you to find the x and y point. You have to give the y point, otherwise you lose your marks. Okay? So here we go. Let's do E. 1E. Y is equal to 2x squared times x minus 3. You can do this in two ways. You can do product rule, or you can do it straight. Now, why is this a product rule or a potential product rule? Is because you've got a quadratic multiplied to a linear. For me, I wouldn't use product rule. I would simply expand this equation because it makes it easier. Expand the equation. You now get 2x cubed minus 6x squared. Find the derivative. This is much easier now. What is the derivative? Delta y delta x. 2x cubed minus 6x squared. Perfect. I've got my derivative, but they want you to find this stationary point. Your line that you have to write. What do you have to write in the next line? Don't just put it 0. What do you have to say? Very good. Stationary point at delta y delta x equals 0. I want you to put that line. So most students will move in from here and they'll do 0 equals 6x squared minus 12x. Don't do that. You will lose a mark. Okay? They want to know why did you just let it equal to 0? Because we do that often. We do it for x-intercepts. We let y equal to 0. We do it for, one of the rules when you're doing factor rule, trying to figure out the factor theorem. You'd let something equal to 0. They want to know what you're doing. So if you don't write it down, especially for this one, they will mark you off. So there has to be a line somewhere that you know the derivative is 0 at the maximum or minimum or at the stationary point. Yep. You would have to say somewhere that it's the stationary point. So you have to refer back to, if they're asking for a maximum, then you say max occurs at delta y delta x equals 0. If you went from here to here, they can penalize you for that. Okay. It does depend on the marks. So you're saying if you just wrote delta y, delta x. I know it's implied, but that's what I'm saying. So examiner, it may depend. That could be a risk that you could take, and maybe it's okay. I'm teaching you not to take a risk. I'm teaching you to, if in case you get a strict examiner, and they're like, that year they're like, everyone's doing it wrong, that it's not correct. They're like, we're going to put a mark if the student doesn't say stationary points occur when delta y, delta x equals 0, you'd then lose a mark if that year they were marking that way. Because what we can't predict is how they mark each year. So each year, sometimes, back in the past, they were okay with negative powers. And then one year, they're like, nah, we want it to be positive powers. Then the students who didn't put in positive powers lose a mark. So it's kind of like you don't know what they're going to do, but you preempt it by doing the best that looks right. And if you do it that, they can't penalize you regardless. So when I teach it, I just make sure that you know what the expectation is, and it's whether you train to do that or not. And to me, it only takes a few seconds to put in a point. Might as well do it. Yeah.
So how would they decide if it's positive indices in a fraction or negative indices for the year? Would they go majority or?
It's been like that now for at least a decade, but yeah, generally it's the curve, because at the end of the day, they want a curve. So wherever they can take marks off, if everyone did really well in that exam, that's why the exams, they don't want it to be easy. If it's easy and everyone's doing really well, the problem is that you don't get a bell curve. You need the top end so that you can say, yep, this kid is clearly the best. So what they do is, if everyone's doing really well, if you had multiple hundreds, they have to go back to the questions and think, all right, which one of these guys seem to do it better than everyone else? So the top of the top. So then they're like, all right, well, that guy was 100, but actually this guy 100 was much more clear in what he did. We're going to penalize by saying, if you don't have this line, you take a mark off. So then they go take off everyone else who was 100, now becomes 99 or 98. That 100 stays as 100. Then you get your curve. See what I mean? And what we can't predict is each year, what's the cohort? Are they better? Are they good? Is the exam easy? Is it hard? We don't know. And because of that, if you're trying to do your best to lay it out, they can't penalize if they decided to do something else. That's why in your layout, that's how I tell. I can pick up your exam paper at the end of this year, and I'll be able to tell what likelihood of where you'll be sitting at, because your layout tells me a lot the way you think. And that's how I predict. I just look at your layout, and I can tell which students are going to do really well and which students aren't going to do well, simply based on your working solutions. That's why it's clear. The top kids I've never seen in my whole entire life of marking so far. I've not seen the top end 40 onwards with a poor layout. It doesn't exist. You just don't get any kids with poor layout and doing really well in methods. It's just how it is. What? Definitely, kids with skipping steps and just getting the answer, even if they're smart, you're never hitting that 40 plus just from the get-go. I can tell you that. So you have to, I think, just working on the layout. I think there's a pattern. When you're laying it out, I think you're more critical. You're much more clear. You can probably proofread. I think that's why those students tend to be the top students generally. Whereas the kids who skip steps, it's because they're weak. They don't know what they're doing, and so they just go, yep, I'll just carry on. And it's very evident. You know what's another evident thing as well? It's a bit more of a personal thing that I pick up on. Kids who write and it's very light. When I see a light handwriting, especially with working solutions, I know this student doesn't know what they're doing, because I think it comes in your confidence. Students who are really strong at what they're doing, it's very clear. When they write, it's so deep. It's like, I know this is the right answer. The kids who aren't, look at their graph. Have a look at one of your top students, and then the ones that you think are struggling with maths. Have a look at their graph. I promise you that handwriting looks very different. It looks very light, fluffy. It's almost like they're hoping that if they did something like this that I won't be able to see, and they're like, I'll give you a mark. No, we don't. We penalize you. If we can't see it, we'll give you a 0. But it's always, from the juniors all the way to the top, I can easily pick up 1 for you, and you'll be able to see what I see. Correct. Yes. So there's this confidence that comes through, and you can see it. You can pick it up just by simply looking at working solution. That's how crazy it is. It's so pattern driven. Okay. So anyways, I lost track where I was up to. I was saying you should have stat. So please write in stationary points, or you can write stat points occur when delta y, delta x equals 0. then you should do 0 equals to 6x squared minus 12x. Yep. For methods? Most of the top students do. It's Spesh that is it. Spesh, from what I was told, that it was designed in some way that it's very rare that you get any students who complete it completely with 100%. So Spesh is different. Methods, doable. Very doable to finish. Exam 2, you should generally on average finish just on time. Top kids will have a few minutes left over. But exam 1, you totally should be having 20 minutes free. So the kids who are doing really well, usually exam 1, so if I write it down, exam 1, most of the students that I've seen that get a 40 onwards, exam 1, they would have 20 minutes free. So 20 minutes free, and they're scoring 80% and above for every exam. So that's how I know as well. So at the end of year, for my year 12s, if I do methods, I would give them practice exams, and then I would ask them, what did you get as your average? If I'm hearing 80% and above, and they have 20 minutes free to check their answers, normally, if they're 20 minutes free and they're checking their answers, it's not 80. They're generally above that. But the 80 would imply that, you just had 20 and you didn't check it well, or you're not at that level, so you're just competing. Whereas the kids who really get it, I've never seen, it's always 80% and above, 20 minutes free. In fact, they're just chilling because they know it's correct. They have no qualms about it. So they're generally in the 90 plus for exam 1. Because exam 1's designed for you to get marks. And literally, we're doing the first page already. We are doing the first page of exam 1. You're getting 2 to 3 marks out of 40. You can see they are designing it so that you get marks. And if you can't get the marks, exam 2 is where they really intensify it. So I normally look at exam 1. If you can't do exam 1, I just keep telling you to go back to do exam 1, because that's how I know if you've got your basic skills or not. And the exam 2, well, that's a different ballgame. That intimidates me too. Exam 2 with extended response is sometimes the wording scares me. Multiple choice, there'll be like 5 questions that is challenging, even with your CAS, or takes long to do. But that's how I know. I just look at your exam 1, I look at your writing, I look at your work solutions. Before I even mark it, I just look at that and I'll get a gist of where you're sitting at. And that comes with experience. Most of the experienced teachers should be able to look at your working solution and be able to sort of guess where you should be. And it's a common thing. You do it so many years, it becomes pattern driven, that these kids with this layout, with this writing, with this thinking tend to be up here, and the kids without it, it's on the bottom. That's how it is. That's why at the start of year, when you handed in that holiday homework, that's all I was asking. I just wanted to see your layout. That's what I was looking for. I wasn't really looking at whether you got it right or wrong. You could have been looking at the solutions. You could have cheated. I don't care. What I'm looking for is how you laid it out. And then that gave me a basis to work with you. That's how I did it. I just wanted to know what you were good at. And so we've been working on graphs. Graphs has been great. So since term 1 to now, you guys have fixed your layout, your graphing. So that's really good. That's what I was looking for. Anyways, answering this question, we're back to delta y delta x equals 0. So factorizing this is now what? 6x bracket x minus 2. Therefore, x equals 0 and x equals 2. Sure? And that doesn't mean you're finished. Okay, so some students will finish here. The question was to find coordinates. Okay, so with coordinates, this is just the x coordinate. You haven't given the y coordinate. So to answer the question, how do I find the y coordinate now? Very good. Not into this function. I see that all the time. They sub x into the derivative function. It's not the derivative equation. It should be going back to your original. Okay? So my original was 2x squared times x minus 3. So 2x squared times x minus 3. So if you sub that in, it should be 2 times 0 squared, 0 minus 3, 0. And the other one would be 2 times 3 squared, 3 minus 3. Again, that's 0. Oh, sorry, it's 2. Whoops, 2. 2 squared times 2 minus 3. So that's what? 4, 8 times negative 1. So negative 8. So your 2 coordinates, therefore, stationary coordinates are 0, 0 and 2, negative 8. Okay, so you can see there, that's a typical maybe 2 marks, derivative correct, and then your stationary point, if it's in coordinates, that's your 2 markers. Okay, but you can see the step, what is the issue? So some students can derive, if they can't, then you're stuck there. But if you can, the next step is, can you factorize? And that's one of the skills I mentioned at term 1. I said you have to know how to factorize because you will get different types here. It could be an e to the x, 2x, whatever it is. You have to be able to factorize. So that's where it sets the difference. It's not the theory. Theory, every one of you will understand what calculus is. It's whether you have the algebra skills. And that's what sets every one of you here differently. Some of you are really good with your algebra skills. Some of you are okay with fractions and surds and arithmetic skills. And those who can't, it's not the theory. It's your basic foundation that I struggle to help. Because that's years of work. That's years of mathematics that you would have done, that if you skipped on it, if you avoided fractions, you avoided surds, you're going to pay for it now. It's going to come up. So that's why you have to build on those skills.
Underlying question.
Yep.
Which I didn't follow.
Yeah, I'm feeling cold too. Maybe I think it's that button.